In the previous video, we introduced the steps for using the substitution method to solve a system of linear equations. I'm hoping that this is a review for you for your previous algebra course, but we'll continue to look at more examples in this video of the substitution method, some special case examples to where you may get infinitely many solutions or no solution, and then we'll look at some application type problems of how we can implement the substitution method for solving the system in those applications. First, we're looking at this solving the system of equations. We have x plus 2y equals 3, 2x plus 4y equals 6, and we want to begin by solving one of these equations for either x or y. And we said it's easier to use the variable that has a coefficient of 1. In that case, that would be the first equation, solving for x. Solve for x by subtracting 2y from both sides. That results in x equal 3 minus 2y. And I'm taking that 3 minus 2y and I'll substitute it into the second equation. That will be written as 2 times 3 minus 2y plus 4y equals 6. And now distributing the 2 throughout the parentheses. 2 times 3 is 6. 2 times negative 2y is negative 4y. Then we have a 4 plus 4y equals 6. And now what you'll notice here is when we combine like terms, negative 4y plus 4y actually cancels out, leaving us with a 0y here. So we lose our variable, and that leaves us with 6 equals 6. Since there is no variable and 6 does equal 6, that means this is a true statement, which means that you can plug any number into y and it will result in a true statement. All right, so we have an infinitely many solutions in this case when the variable cancels and we're left with a true statement. Now there's an infinite number of solutions, but that doesn't mean every ordered pair is a solution. Right? Every point on that line that we would graph, right? If we were to graph both of these equations, we would get the same line. Right? So every point on that line is a solution. So we want to find an expression, right? A general formula for expressing this solution of this system of equations. Right? So we're going to have, right, an ordered pair. Right? We're going to have this x comma y, and typically how this can be expressed is that we let x be any real number. We say let x be any real number, so we're leaving this x as it is, and then we'll write y in terms of x. We can do that by taking either equation, since they're the same equation actually, and solving for y. Okay, so let me take that first equation, that x plus 2y equal 3, and solve for y by subtracting x from both sides. And then divide both sides by 2. That's y equal 3/2 minus 1/2 x. So the solution would be written as x comma 3/2 minus 1/2 x. This would be all the ordered pair that satisfies this system of equations. These are all the ordered pair that lies on that line. Okay, so you can plug in any number into x and it will give you an ordered pair that lies on that line. Okay. Depending on the type of equation that you have, pay attention to how the directions are wording in this. Sometimes, and it depends on the textbook, it depends on the online homework system. But there are times to where it may want you to write the ordered pair in terms of x. The directions also may specify to write your answer in terms of t. Right? So if it says something about write your answer in terms of t, instead of writing your answer in terms of x, you just write this t. Nothing really magical about that, right? X is just a variable, right? So it doesn't matter what you call that variable. You can call it X, you can call it T. Same thing. So pay attention to those directions and note how they want you to write that variable, right? So, but this is, right, either one of these, depending on the directions, is the solution in the case where you have infinitely many solutions. And on a test, I don't want you to write infinitely many solutions. I want you to write this general formula for the ordered pair of the solutions. Okay. All right, let's move on to a second example. Solve a system of equations 3x minus 2y equal 5 and 6x minus 4y equal 2. In this case, there are no variables with a coefficient of 1. So it doesn't matter which equation that we start with. Doesn't matter if we solve for x or y. Just pick one. And typically, I'll just start with the first equation and solving for y. So to solve for y, when you get y by itself, we'll begin by subtracting this 3x from both sides. That's negative 2y equal 5 minus 3x. And then divide both sides by this negative 2. So that is y equal 5 divided by negative 2. I'm going to write as negative 5 halves. Negative 3x divided by negative 2 is positive 3 halves x. All right, and so now we substitute this into the y of the second equation. And this results in 6x minus 4 times negative 5 halves plus 3 halves x. That's equal to 2. Okay, now distribute this negative 4 throughout the parentheses. Negative 4 times negative 5 halves is a positive 10. That's 4 times 5, that's 20 over 2, reduces down to 10. And negative 4 times 3 halves is negative 6x, because 4 times 3 is 12. 12 over 2 is 6, equals 2. Notice, same thing happens here as the previous example. When we combine like terms, 6x minus 6x cancels. But unlike the previous example, we have two different numbers set equal to each other. 10 does not equal 2, so this is a false statement. So it doesn't matter what you would plug into x, it would never satisfy the solution. When we get this false statement, that means that there is no solution. Graphically, that means that these two lines are parallel and do not have an intersection. And you may want to, on your own, graph these two equations to see that they are in fact parallel. And in the case where there's no solution, this is how you would write your final answer, just as a no solution. All right. So those are some examples of just a regular substitution method with this algebraic examples. What about if we had some applications here? They'll work the same way. The only difference is we will need to formulate our system of equations. In this example, we have Michael that has a total of $2,000 on deposit with two savings institutions. One institution pays interest at the rate of 3% per year, while the other one pays interest at the rate of 4% per year. If Michael earned a total of $72 in interest during a single year, how much does he have on deposit in each institution? All right, so you're going to need to be able to read a word problem, understand what it's asking you, and understand what information that they're giving you. Okay, so we have two things happening here, right? We're given information about how much he has on deposit. I'm going to write this down. All right, so we have information about how much he has on deposit. right? He's got $2,000 on deposit. All right, some at institution 1, some at institution 2. We don't know how much. So we can call, let's see, institution 1, institution 2. We don't know how much he has in the first institution, so we'll call that X. We don't know how much he has in the second institution, but it could be a different amount, so we'll call that Y. I'll just say the total here. I'm setting up a table. Okay, so we know information about the deposit. We know the total deposit. We don't know how much he deposited individually into the 2 institutions, but that's what we're trying to find out. How much does he have on deposit in each institution? So we're trying to solve this XY. And in our solution, right, that'll be an ordered pair. So we need a system of equations, right? If we're trying to solve for an X and a Y, in order to solve for the X and Y, we need a system of 2 equations, right? So we need 2 equations here. The other piece of information that they give us is we know how much he earned in interest. Now, he made $72 in interest total. We don't know how much he made in interest from either institution, but we do know that the first institution pays interest at the rate of 3% per year, right? And if he has X dollars deposited, then he would earn 0.03X in interest, right? Just multiplying the amount that he has invested times that 3%, the 0.03. And the second institution pays 4% per year. So we would say that he earns 0.04 Y dollars in interest. Okay, so we're writing everything that we're given. We set that up as a table. That's going to help us stay organized and help us be able to identify the 2 equations that we're using better. All right, so our 2 equations are going to involve our 2 relations, the deposit and the interest. Okay, and we already, in a sense, have these equations, right? We know that the total is equal to the sum of the institutions, and the interest is equal to the sum of the interest from each institution, right? You see the equations there, right? 2,000 equals X plus Y, and 72 equals 0.03X plus 0.04Y. And now once we have the 2 equations that we have, then we can proceed with the substitution method. Finding these 2 equations is the difficult part. The easy part is using the substitution method to solve for X and Y. All right, so we'll go back through our substitution method steps to where we solve one of the equations for one of the variables. I'll solve the first equation for Y by subtracting X from both sides. So Y equals 2,000 minus X. And then I'll take the 2,000 minus X and substitute it into the second equation. And we have 72 equals 0.03X plus 0.04 times 2,000 minus X. Okay, distributing the 0.04. 0.04 times 2,000 is 80. 0.04 times negative X is negative 0.04X. And now combine like terms. 0.03X minus 0.04X is negative 0.01X. Then subtract this 80 from both sides. 72 minus 80 is negative 8. And then finally divide both sides by 0.01. Negative 8 divided by negative 0.01 is 800. That's X. X is the amount that Michael deposited in institution 1. We also need to know how much he deposited in institution 2. And we can find that easily, probably just by looking at it in this particular case, right? Because if he deposited a total of 2,000, he deposited 800 in institution 1, you might be able to say, well, I know he deposited 1,200 in institution 2, following the substitution method, right? Substitute 800 into the X in this Y equal 2,000 minus X. 2,000 minus 800, that's the 1,200. Okay. So 1,200, that's the institution 2. The 800, that's the institution 1. Okay. And we'll look at one more example here. Again, the difficult part is writing out the equations. Okay. So let's pay particular attention on being able to write out the equations. The total number of passengers riding a certain city bus during the morning shift is 1,000 people. If the child's fare is 50 cents and the adult fare is $1.50, the total revenue from the fares in the morning shift is $1,300. How many children and how many adults rode the bus during the morning shifts? Okay, so what are we trying to find? We're trying to find the number of children and the number of adults. All right, so we've got two unknowns that we're trying to find. Okay. If we have two unknowns, we need two equations. Okay, so we've got two equations. What two pieces of information are we given? Okay, we're given information about the total number of passengers, and we're given information about the revenue from the fares. So that's going to be our two pieces of information that's going to be related. That's where our two equations are going to come from. Okay, and if you like the table format, then you can set that up as we did before, to where we had, the total. We had, in this case, the categories are children and adults. And there were a total of 1,000 passengers. We don't know how many children, we don't know how many adults. That's where the X and Y come from. It's like that as variables. And the fares, we know that we had a total of $1,300 in fare. And now how much did we collect in fares from the children? Well, we don't know how many children, but we do know that we collected 50 cents per child. So if we have X number of children, then that would be 50 cents times X, 50 cents times the number of children. And then the $1.50 times the number of adults. Okay. And so this gives us our two equations, right? 1,000 is equal to the X plus the Y. The 1,300 is equal to the 0.5X plus the 1.5Y. And then we can proceed with the substitution method as we've done previously. And we can solve the first equation for Y by subtracting X from both sides. Y is equal to 1,000 minus X. Substitute that into the second equation. 1,300 equals 0.5X plus 1.5 times 1,000 minus X. Distribute the 1.5. 1.5 times 1,000 is 1,500. And 1.5 times negative x is negative 1.5x. Now combining like terms. 0.5x minus 1.5x is a negative 1x. So now subtract 1,500 from both sides. 1,300 minus 1,500 is negative 200. That's negative 200 equals negative x, so divide both sides by negative 1, and we get an answer of x equals 200. Right? X represents the number of children, so we know now that 200 children rode the bus during the morning shift, and we also can gather that 800 adults rode that bus.